Now, the Egyptians were so accurate with their measuring device that they were able to invent the solar day, which was the start of our solar calendar and was differentiated from the lunar calendar, which many other groups used at the time. Let's talk about that solar day and how they picked it up. They were thinking that the Earth was at the center of the universe, and they noticed that there was a difference between two time periods for a day. One is called the Sidereal day, and it is effectively 23 hours and 56 minutes long. And that's important because let's look at what the Sidereal day really is. If you start the day and you start it up here at a point A, and the Earth then rotates, it would come back to a point where in the star-filled sky, you would have the same stars right above you at that point. So here's A where it starts. The stars are aligned. A is here. 23 hours and 56 minutes later, the rotation happens and you're here where the stars are aligned. And at that same time, the Earth has revolved around the sun and moved approximately 1 degree of the 360 degrees. The Egyptians were so precise that they could pick up the fact that the Earth was now in a place where it was aligned with the stars again, but it was not aligned with the sun. In other words, at B here, the gaze from A does not go back to the sun. So the look of the sky is not quite the same. But the sidereal day is based on the Latin word sidus, as with the stars. And if you look at the far off stars, you're in great shape. It's just the close star, you're not where you were before. The solar day adds 1 degree in the turn of the rotation. And as a result, where we started with A straight on to the sun, now we end up 1 day later, 1 degree farther along the annual motion of the sun, and you have traveled another degree in 4 minutes. And your day is 24 hours long, not 23 hours and 56 minutes. This is called a solar day at 24 hours, accounting for the degree that you moved in revolving around the sun. The Egyptians used solar days in their calendar, and that was quite important. Let's go into why. There's a big difference at 4 minutes a day over the course of an entire year. If you do the math, over the course of the entire year, you're adding 1 more day when you use solar days. So you could get to a very accurate calendar by using solar days. And think about it, our calendar is accurate at 365 days per year, but even now, we must add 1 day every 4 years, leap year. And that's always a hassle doing that. And there's always some confusion that's around a leap year. Last year was a leap year. So, was it this year? No, this year was the leap year. So if you can think about the confusion that we note every 4 years with leap year, think about adding a day every year in 3000 BC Egypt when there's not the internet and there's not easy forms of communication to get the word out. So the Egyptians used the solar day. They were very accurate in your calculations, and it all comes from that carpenter's frame. Hope that helps. This carpenter's frame, while accurate with its calculations, still held that paradigm that the Earth was at the center. And they were measuring the diurnal rotation of the Earth at the center of the universe. See you on the other side.